Hi, my name is Matthias. I'm a mathematician. I worked at Sahatit Architects as a senior researcher, and now I'm a freelance consultant specializing in numerical partial differential equations. And as such, I want to give you a brief overview of the paper Conductive Heat Transfer and Thermal Bridges that has just appeared in Encyclopedia. Nowadays, engineering necessarily relies on a good deal of energy performance analysis whenever you want to do any kind of housing project in the moderate latitudes. So typical questions are: what is the energy loss at a given temperature difference? Do we need some insulation? Is the inward facing temperature above the local dew point? And so on and so on. And to answer these kinds of thermal engineering questions reliably, you would actually have to perform a finite element analysis, but when you look it up in the textbooks, you find that those usually just treat structural analysis, computational fluid dynamics. So this is a much more complicated and more difficult setting. And when you look it up in math textbooks, actually what they do is they treat some kind of heat equation which differs in some term by the one we need. So actually we need here some different term. So what does this mean? Actually, we want to treat a simple equation delta kappa delta U equals 0, but this is something you will not find in the literature just for the case of thermal engineering. So what I did all this work for you. I managed my way through all engineering texts and all numerical textbooks on finite element analysis, and I wrote down for you what it means to perform the numerical solution, the finite element solution of the heat equation just for the case of thermal engineering. So we define what a thermal bridge is, we show what types of heat transfer there are. I give you a complete crash course on all relevant physical terms, the U values and so on. We go through analytical examples, and then we go through all the points, boundary conditions, meshes, the weak formulation, and at the end, reading this paper actually puts you in a position where you can, at least in principle, implement your own finite element analysis from scratch. Check it out. Thanks for watching.